What is Retrieval Augmented Generation? Well, a short and direct answer is that RAG is a technique that gives a large language model the ability to look up information before answering a prompt. Let me illustrate what I mean. Imagine that you're sitting in a classroom taking a difficult final exam. You're not allowed to use any notes or resources at all. You're sitting there sweating and anxious, working completely on memory. You might be brilliant, sure, but if you didn't memorize that one specific detail, you're stuck, and you might end up taking a wild guess and hope for the best. Now, let's imagine a second scenario. This time, your teacher walks over and hands you the entire textbook to help you with the test. Suddenly, the pressure disappears. You just flip to the right page, find the exact information you need, and write down the perfect answer. You'll still have to understand the material to write the response, but you don't have to rely solely on your shaky memory anymore. In this analogy, you, the student, are the large language model, and the textbook is the external knowledge source, and the actual act of opening the textbook to find the answer, that's RAG. So to give you the more formal definition, RAG is an AI technique where a language model first retrieves relevant information from an external knowledge source, such as documents, PDFs, or databases, and then uses that information to generate a more accurate response. In simple terms, RAG is all about search first, answer second. So what's the point of RAG? Well, RAG helps solve one major problem with large language models: hallucinations.
I see dead people.
No, that's not the kind I'm talking about. You ever ask ChatGPT something and it gives you an answer that's completely wrong, and yet it says it with complete confidence? That's what we call a hallucination in AI. A hallucination happens when the model generates information that sounds believable, even though it isn't based on real facts or trusted data.
Wrong.
It's like that one friend who thinks they know what they're talking about, but really they know, well, nothing at all. The reason these hallucinations happen is because of two big limitations of large language models. Number one is that there's no built-in source. A standard large language model usually answers from what it learned during training. This means it's limited to generating response only on data that it's seen before. So what does it do? Well, without direct evidence, there's a higher chance that the model will just make stuff up. Number two is that the information can be out of date. As we very well know, the world is changing constantly. Policies change, research evolves, company products change as well, and we damn sure know that prices change. If the model was trained on older data, it may give an answer that's completely outdated. That's the thing about language models. Even if it doesn't have a reliable source or has outdated information, it still tries to produce the most likely answer. It's not intentionally lying, but it's more like the model is filling in the blanks with its best guess. And that's where RAG flies in like a superhero saving the day. It solves both of these problems by giving the model both a reliable source and up-to-date information. So now that you know why RAG exists, how does it actually work? Well, RAG has three simple steps, and fortunately, it's right there in the name: retrieve, augment, and generate. Yes, that's literally where the name comes from. Let's break each one down. Step one is retrieve. When you send a prompt or ask a question, instead of the large language model immediately jumping to the answer, the system first goes out and searches for relevant information. This could be searching a database, scanning through a collection of PDFs, or even searching the web in real time. Think of it like a language model raising its hand and saying, "Hold on, let me look that up first," before opening its mouth. Step two is augment. Once the system retrieves the relevant information, it takes that content and attaches it to your original prompt. So instead of just sending the language model your question, you're sending it your question plus the relevant context it just retrieved. You're essentially handing the model a cheat sheet before the exam. Step three is generate. Now the language model does what it does best. It reads the retrieved context, combines it with your original question, and generates a response. But this time, instead of guessing or filling in the blanks, it's now working with actual, relevant, and up-to-date information. So the whole flow looks like this. You ask a question, the system searches for relevant info, that info gets attached to your prompt, and the large language model answers based on what it just retrieved. Alright, so now that you understand how RAG works, there's one really important piece we haven't talked about yet, and that's the retrieval layer, aka where the model actually gets its information from. And that's where today's sponsor comes in. This video is sponsored by SERP API. If you're building anything in AI or machine learning, you already know that data is everything. The problem is getting real-time structured data from the web is honestly kind of a nightmare. SERP API basically handles all of that for you so you can focus on building your app. It lets you pull real-time results from Google, YouTube, and more, and gives it to you in a clean JSON format. This is huge for training your machine learning models because you can build custom datasets with pre-classified images, URLs, and even full metadata from peer-reviewed articles using their Google Scholar API. And if you're trying to build impressive portfolio projects and actually stand out, you need real, live data from the web. Whether you're building a news dashboard, a price monitoring service, or a RAG system like we talked about today, SERP API lets you supercharge your app with millions of data points from all the top search engines. It's built for developers who need reliable data fast. We're talking over 99.9% uptime and an average response time of just 1.2 seconds. What you see in a Google search is exactly what you'll retrieve from their APIs. Click the link in the description below or scan the QR code to create your free account and get access to your first 250 credits immediately. Now let's get back into RAG. So how exactly are these 3 steps carried out in reality? The architecture of RAG isn't just one technology. It's actually a pipeline of a few different components all working together. Let's walk through each one. First up are embeddings. An embedding is basically a way to turn text into numbers, because that's the only thing that AI models understand. When you feed text into a RAG system, the system converts it into something called a vector, which is just a long list of numbers that represents the meaning of that text. Next up are vector databases. Once your text is successfully converted into embeddings, they need to be stored somewhere. That's where a vector database comes in. Think of it like a regular database, except instead of storing rows and columns of data, it stores vectors. These specialized databases are specifically optimized to search through those vectors really quickly. These vector databases are a pretty big deal in the RAG world. Then we have the similarity search, also known as the retrieval layer. This is where the magic, or in other words, the math, happens. When you ask a question, your question gets converted into a vector. The system then goes into the vector database and asks, which of these stored vectors are closest to my query vector, aka the question. That process is called similarity search, and to understand it, we need to talk about vectors for a second. We can actually measure how similar 2 vectors are, and the way we do that is through something called cosine similarity. Now, don't let the math scare you. The intuition is actually really simple. Imagine 2 arrows shooting out from the same point. If these 2 arrows are pointing in roughly the same direction, the text they represent has similar meaning. If they're pointing in completely opposite directions, the meaning is totally different. Cosine similarity is just a mathematical way of measuring that angle between the 2 arrows. All this is saying is take 2 vectors, A and B, measure how much they point in the same direction, and return a score between -1 and 1. A score of 1 means they're identical in meaning. A score of 0 means they're completely unrelated. And anything negative means that they're basically opposites. So to recap, when you ask a question, your question gets converted into a vector. The system then compares that vector against every document vector in the database using cosine similarity. It scores each one and returns the ones with the highest scores. These are your most relevant documents. That's it. The system isn't reading the words, it's comparing the direction of meaning mathematically. Low-key one of the coolest things in all of machine learning, if you ask me. And finally, the large language model. Once the similarity search returns the most relevant documents, Those get handed off to the large language model along with your original question. And now the large language model has everything it needs: your question plus real relevant context to generate an accurate, grounded response. No more hallucinating. At the end of the day, RAG turns AI from something that guesses into something that actually knows where to look. And that one shift is what makes modern AI systems so much more useful in the real world. If you're interested in diving deeper into machine learning specifically, I've created a free machine learning ebook designed to simplify the learning process and break down complex concepts into digestible, practical lessons. Just click the link in the description to sign up and get your copy. Whether you're just starting out or looking to strengthen your foundation, it's a great resource to have in your toolkit. Thank you guys for watching, and I'll see you in the next video.